Welcome to Networking and Health Information Exchange Health Data Interchange Standards. This is Lecture A. In this unit, we will talk about the different standards that may be used to share health data among disparate groups, frequently identified as messaging standards. Lecture A focuses on Health Level 7's version 2.n Messaging Standard. The objectives for this unit, Health Data Interchange Standards, are to understand the need to have data standards, understand the standards that are in place today or are being adopted, learn about HL7 standards and implementation, and understand HL7 messaging standards and the basic HL7 transaction types. Why use data interchange standards? If we need to create a patient-centric EHR, then we must aggregate data from all sites of care. Persons see many different doctors in different places for a variety of reasons. In many cases, the person is likely to be taking medications prescribed by more than one doctor. Clearly, it is desirable to be able to aggregate this data. Further, multiple uses of the data, referred to as secondary uses of data, require the exchange of data. For many reasons, the sender and receiver of data may not be predictable or known in advance. In this case, a data interchange standard is a necessity.
Similar to any communication, the data exchange will include physical things, such as persons, lab tests, medications, appointments, diagnoses, etc. Nouns that are subject of the interchange. Next are the relationships between nouns, such as a doctor ordering a lab test for a patient, or an admission or a patient encounter. These relationships are expressed as phrases and represent a binding between nouns. Examples include an action that happens to a person, an action that causes another action, or a person performs an action. The language of communication included in the message is most critical. We must prescribe the nouns and phrases that we can use and what they mean. The data model and the terminology are used to define the nouns and phrases. These terms must be generally understandable in order for the exchanged messages to be understood and used. There are several choices for the exchange of data. The most commonly used data interchange or messaging standard used in the U.S. today is a Health Level 7, HL7 messaging standard known as version 2.n, where n is the current version. Many versions are in use today, but current standards specified by meaningful use criteria are versions 2.5 or 2.5.1. The latest version from HL7 is V2.7 with V2.8 in ballot. All version 2 standards are backwards compatible, so basically newer versions add functionality to the standard. We will discuss the V2.n standard in detail in this lecture. Data may be exchanged as a document, where the content of the document is defined by a schema. A common document exchange standard is the HL7 Clinical Data Architecture, which we explored in Unit 4. A constrained version of the CDA, defined to accommodate the exchange of summary clinical data, adapted from ASTM CCR, is the Continuity of Care document, basically an implementation manual based on the CDA. ASTM has produced a similar standard called the Continuity of Care Record, which can also be used to exchange a patient summary record. The contents of the CCD and the CCR are similar, and both use XML syntax. For the exchange of images and other media, such as waveforms, the DICOM standard is used. ASC X12 produces a family of standards to support the claims reimbursement data exchange. NCPDP has a set of standards that support the exchange of prescription data for e-prescribing, as well as for reimbursement of medication products. Since it is likely that you will be using the HL7 V2.n standard in your healthcare environment, it will be presented in detail in this lecture. The popularity of V2.n is that it is easy to use and understand, and easy to implement. The standard is based on an implicit information model. The messages are defined to support certain data elements that are defined through the experience of the designers for a particular event. This standard was initially created to support building a hospital information system from components from different, multiple vendors. This approach has been referred to as best of breed, but it actually supports the approach of most settings in buying whatever systems they like and connecting them together. Without a standard, the required interfaces between systems would be cost prohibitive. This cost is reduced by several orders of magnitude through the use of standards. Messages in V2.n are organized around events, and the messages are divided into subsets that convey information about the event, the patient, the encounter, the act, the results, and other functions. V2.n messages make no attempt to define process. Further, as the standard evolved, additional data elements were added to the appropriate components in sequence as the need for the data element was discovered. The simplicity of V2.n messages is its popularity. Within a single enterprise or in an environment in which sender and receiver are known, business agreements, including what data elements will be exchanged, what terminologies will be used, and when the data will be exchanged, a tightly coupled environment, works very well. Today, most exchanges fit this specification, even with large geographical areas. However, as we expand data exchange across boundaries, nationally or even globally, these agreements are not in place, and a messaging standard based on an explicit model must be used to achieve interoperability. Hence, the V3 standard to be discussed in the next lecture. V2.n is not an interoperable standard. The original V2.n standard specified what data elements were to be exchanged by defining the position of that data element in a specific message component, and the data elements were separated by delimiters. The data exchange structure is hierarchical, with repeating segments accommodated. Delimiters were chosen to reduce the number of characters necessary to be transmitted, since at the time of the creation of the standard, available bandwidth was very limited. The result of the delimiter syntax is that the overhead of a V2.n message is about 5%. To take advantage of XML tools, V2.n has been modified to accept an XML syntax. This construct will be discussed in a later slide. When and what data is exchanged is defined by a trigger event, such as patient admission, patient discharge, patient transfer, lab test order, lab result reporting, etc. Clinical data is sent by the name of the data element and the result of value of the test, so-called name-value pairs. HL7 messages are composed of reusable components called segments. Each segment is identified by a 3-letter mnemonic. Segments are content-oriented, that is, focused on such things as the patient, the visit, the act or event or activity, or the thing. Which segments are used in a message depends on the message type. The message type is associated with a trigger event. Fields may be repeating. For example, if more than one provider is identified, all may be included by using the repeating field construct. A segment is made up of data fields. We will learn more about this construction in the following slides. HL7 has not chosen a specific terminology, but maintains a registry of controlled vocabularies, and the terminology is expressed as a triplet: code, text name, and controlled vocabulary identity. For example, LOINC is represented by LN. SNOMED is represented by SM. As V2.n developed, the standard was unable to stay ahead of the user requirements. Consequently, a provision was made for user-defined segments identified by the first letter Z in the mnemonic name. The good part of Z, or local segments, was that the user could send anything. The bad thing was that users never reverted from the Z segment to an actual HL7 standard segment when the standard caught up with the requirements. Obviously, the Z segment is a trade-off between accommodating local needs and true interoperability. There are messages for specific events. The HL7 V2 messages are hierarchical, starting with the message composed of segments. The segments in turn are composed of data fields, which in turn are composed of components, which are further subdivided into subcomponents. This construct was delimited by a defined set of delimiters. The data fields were separated by the filter bar, components were separated by the caret or up arrow, and subcomponents by the ampersand. The squiggly bar was used as the repetition separator. The backslash indicated that an escape character followed, which would be an ASCII code. This permits sending special characters, such as bold or italics or tabs, etc. Every segment must be terminated by a carriage return. Segments are limited by length, as are data fields. Messages are composed of reusable segments, each identified by a 3-letter mnemonic. All messages must start with a header, MSH, much like the addressing of an envelope in regular mail. The header segment tells us who is the sender and who is the receiver, the date and time, a unique message identifier, the message type, and the trigger event, and the version of HL7 V2.n being used. Segments used in a message are determined by message type. This graphic illustrates the basic HL7 transaction model. A patient is to be admitted to the hospital. It is important to make a number of service systems within the hospital become aware of the admission, along with the identifying characteristics of the patient. This example illustrates informing the lab system of the event. The admission process is a trigger event and activates the sending of a specific message type to one or more receivers. In many cases, the message is sent to an interface engine which knows the set of receivers to receive the message and sends the message to each of them. The example shown here is the admission of a patient, and we want to notify the lab of the admission along with data about the patient and the admission so they can start a record for the patient in the lab system. An admit message, ADT, is triggered by the trigger event, AO1, and sent through the network to the lab system. The lab system acknowledges the receipt of the ADT message by sending an acknowledge ACK message to the sender. This acknowledgement is simply a communications receipt and not an indication that the lab will fulfill the request. That acknowledgement is a separate acknowledgement that says message received and understood and would be carried out. Summarizing the previous slide, the trigger event is A01, the message type is ADT, and the message includes data about the patient, the PID or Patient Identification Segment, and the Patient Visit Segment, PV1. Additional segments may be included. For example, an admitting lab order could be included or other information could be included. This slide shows the composition of the message header segment, MSH. Note that the delimiters are included as part of this segment in a specified order. In an attempt to provide total freedom, HL7 permitted the definition of the delimiters. In practice, all uses of HL7 version 2.n use this standard set of delimiters. The other components are the sending unit and sending place, the receiving unit and receiving place, the date time following the date time data type standard, 4-digit year, 2-digit day, 2-digit month, 2-digit hour, 2-digit minute. Next, a password is included, then the message type and trigger event as a component, the message number, the P indicating a production message in contrast to a test message, and finally an indication this is version 2.7. The carriage return terminates the message. Note the use of the filter bar to separate the data fields and the up arrow to separate the components. This segment is the Patient Identification Segment, starting with the segment identifier PID. This slide shows the first third of the segment. The patient identifier is the first data field with additional components of a check digit, 5, and the method for calculating the check digit, modulo 11. The second field is for an external identifier. The third field is for an internal identifier, and the fourth field is for an alternate identifier. None of these fields are used, so each data field is made null. The delimiters must be included to keep the positioning of the data fields in the correct order. Next is the data field patient name. The patient name is expressed by 4 components: last name, first name, middle name, and suffix. The standard also allows for a prefix component, but it is not used in this example. Note that the delimiter is not required, since it is not necessary to retain the sequence of fields. What would you do if the patient had 2 middle names? In this case, sender and receiver would need to reach an agreement as to how that would be accommodated. In most cases, the middle name is assumed to mean all other names. Is the last name the family name or surname? Depends on nationality or country of the individual. These issues have been resolved through the use of data types. The PID segment continues with mother's maiden name, date of birth, using the date-time data type, gender, patient alias, which is null, race, and the first part of the address data field, the street address. The address data field continues on the next slide. Finally, the last part of the PID segment continues with components city, state, and zip code. County is next, followed by the telephone number, whose format is also defined by a data type. Finally, the carriage return terminator ends the segment. The PID segment has many additional fields and even accommodates animals. You will need to obtain a copy of the HL7 version 2.n standard to see the complete definitions. A simple way to implement this standard is to create a matrix which maps the HL7 data fields to your own database. Next is the patient visit segment, PV1. There is also an additional segment to extend data about the encounter called PV2. The data field following the segment identifier is known as the sequence number and permits the contents of this segment to be sent as multiple lines, but no carriage return except on the last. These lines are numbered in sequence 1, 2, 3, etc. Next is a coded patient class, followed by patient location, ward and room, followed by admission type, null, admission number, null. Position 6 is prior patient location, and data field 7 is the attending doctor field, broken down into components, provider code, last name, first name, and middle initial. The next field is referring MD, null, followed by the service of the attending. The segment is terminated with the carriage return. Again, many additional fields as well as a second segment provide the opportunity to include a large amount of data about the visit. By now, you should begin to understand the V2 messaging standard, how easy it is to use by just filling in the blanks. On the receiving end, you pick up the pieces you want and put them into your own database. The next few slides show some other segments to give you an idea of how the messages and data exchange work. In this case, we see the Observation Request segment, OBR. Its contents include the placer order number and the filler order number, so either can trace the message. There is a Universal Service ID, which includes the components of ID, text name, and L for local terminology, the triplet previously mentioned. Priority data field is null, followed by date time of the request. Next are a series of data fields that are null. Other data fields include reason for the study and the principal and assistant results interpreter. Again, this slide shows a typical order result message. In this case, the segments include the header, the patient identifier, the order request, and 2 result segments. The OBX segment is examined in detail in the next slide. The last OBX shows the hierarchical nature of the segment. The test ID data field is broken into the triplet of code with check digit, text name, and vocabulary source, LOINC. OBX is the most flexible segment and can be used to send almost any data. With this segment, supported by other segments, the entire contents of a medical record can be sent. The third data field is for data type, in this case numeric, NM, so the results can be properly interpreted. Again, the test name is the triplet of code, name, and vocabulary source. The numeric data value is in position 5, and the units are specified in position 6, so the interpretation is 38 degrees centigrade. The F in position 11 indicates that it is a final result. Also, note the name-value pair construct. Other data fields include date of observation, identity of provider making the observation, normal ranges, and abnormal flag. It is indeed a powerful segment. Messages can include any number of these segments. This OBX segment example shows a data type of coded, CE. In this example, the test name is specified by a LOINC code 883-9, and the result is a coded value from SNOMED. This test is for blood group, and the value is Group O, a SNOMED code of F-D1250. Note, this construct is referred to as a name-value pair. This message shows a typical V2.4 message. The segments illustrated are MSH, Message Header, EVN, Event Segment, PID, Patient Identifier Segment, NK1, Next of Kin. This segment illustrates the use of the sequence numbers 1, 2, and 3. This message continues on the next slide. Here are some additional segments, including patient visit segments PV1 and PV2, result segments OBX, diagnostic procedure DG1, guarantor GT1, and insurance IN. The richness of this standard can be appreciated. Note the segment terminators CR are not shown. With the popularity of XML and its widespread use, HL7 developed an XML-based version of V2 messages. In this case, XML syntax replaces the delimiters. This example shows the use of the XML delimiter. In contrast with V3.0 messages, which have XML tags that identify the data elements, these tags only identify the segment and position in the V2.n segment. This method permits the use of XML tools to display and process the messages. This slide shows functional areas covered by V2: ADT, registration, orders, results, patient financial, query language, immunization reporting, clinical trials, adverse drug reactions, scheduling, referrals, medical records, patient care, problem lists and goals, waveforms, personnel management, clinical lab automation transactions, and master files. This concludes Lecture A of Health Data Interchange Standards. HL7 V2.n messages are used in over 90% of the hospitals in the U.S. Different places use different versions, but they are backwards compatible. You should now feel comfortable if you were asked to create an HL7 V2 message. Of course, you would need to obtain a copy of the standard to see all of the segments and data fields. Use of the HL7 standards requires joining HL7 or buying the standard. Clearly, if sender and receiver are in communication, V2 gets the job done.